In this lecture, I walk with you through the fundamentals of TensorFlow. TensorFlow is a Python open source library for numerical computation that makes machine learning faster and easier using data flow graph. It is created by Google and has API available for multiple languages such as Python, C++, Java, etc. It is suitable for both production and research with multi-GPU support. GPU here stands for Graphical Processing Unit. And it has TensorBoard for visualization. Also faster model compilation than Theano. If you have used Theano, then you can see. And it has high-level API built on top of TensorFlow, such as Curse, such as TFlearn. In order to work with TensorFlow, the typical setting include Anaconda, which is the package manager. Anaconda comes with Python when you download the software. And then you can download and install TensorFlow. And you work on the IDE, which is the code editor, such as Spider, such as PyCharm. This is the trending on several deep learning libraries. Basically, you can see the comparison between TensorFlow, Theano, PyTorch, and MaxNet. At about in March, roughly March 2016, you can see the interest increase and increase very much higher than others between TensorFlow and the rest of the libraries. This slide shows the interest for TensorFlow across the country and between from state to state. What can machine learning do? This slide shows two examples. On the first example, it is a game where a neural net tries to guess what you are drawing. So basically you try to draw on a screen. And the machine learning model behind the scene tells you what you are drawing. And on the second example, it is auto draw, fast drawing for everyone. You draw and it finishes. It tries to finish as best as it can. You can see more, check out more example on experiments.withgoogle.com. Now let's go in and see what a tensor is. A tensor is a multi-dimensional array. It can be zero-dimensional, one-dimensional, or two-dimensional. The zero-dimensional tensor is also called scalar. The one-dimensional is a vector, and the two-dimensional tensor is a matrix. The full documentation is on the website www.tensorflow.org. Before working with TensorFlow in your code, you would first have the line saying import TensorFlow as TF. The alias can be anything, but TF is commonly used. TensorFlow uses the computational graph approach. Basically, it builds the graph which represents the data flow of the computation and later on runs the session which executes the operations on the graph. So on this graph, it builds a graph for this w times x plus b. And we can see there are two operations. Matmul stands for matrix multiplication, and add. If we run the session on the tensor generated by the add operation, then we get the result. Now first let's look at constants in TensorFlow. Constants are used to create constant values. So let's look at this example. There are two constants, s and m. So in order to create a constant, you write tf dot, tf is the alias for TensorFlow. So tf dot constant is to create a constant. What is the value of the constant? You give it here. And what is the name of the constant? This is optional. You can also give a constant a 2D list like this. And this is a 2x2 list, and give it a name matrix. So once I have the two constants, the two tensors, right, s and m, I would create a session, a TensorFlow session, using the structure with tf.session as ses, so that later on I can just use ses instead of tf.session, which is long. And I can print out the result. So in order to evaluate s and m, I have to write I have to write ses.run and give it the tensor s, and I also write another which is ses.run, and I give it the tensor m. So it would print out the output for me, which is 2, and which also the other is a list, a 2D list. And on the right, this is syntax for tf constant. Next, we look at variables in TensorFlow. Variables are used to hold and update parameters. In order to create a variable, you write tf dot, this is the first thing, and then variable. You give it the initial value and the optional names. And this is optional, so you don't have to put name there, but it's good to do. TensorFlow variables must be initialized before they have values using tf.initialize all variables. This actually was deprecated, so now you use this instead. So you are going to run a tf.global values initializer method instead. In this example, first you import TensorFlow, give it an alias, and then this slide creates a constant with a shift 2 by 2. And the next line creates a variable. The input for variable here is a 2D tensor. And it can also be a 2D list as well. So you have two tensors, A and B. Then you create a session with tf.session as ses to evaluate the tensors A and B. And because B here is a variable, so before the line print ses.run B to evaluate B, you will need this line ses.run tf.initialize all variables to initialize variables. And actually for now you would run this is that tf.global variables initializer. Next we look at placeholders. A placeholder is a variable that is assigned data to at a later time and allowing to create operations and build computation graph without needing the data. So in order to create a placeholder, you use to write tf dot placeholder, and then give it the data type, which is float 32, following the syntax. So we have node 1 and node 2 as the two placeholders. And node 3, add them together using tf.add. In order to evaluate node 3, you run the session object tf.session.run and give it node 3. Also another argument which tells the value that need to pass to node 1 and node 2. The argument is feedict, right? And you give it a dictionary saying what you want to pass to node 1 and what you want to pass to node 2. And running this would return 5. Let's look at operations in TensorFlow. tf.add returns x plus y, and this is element wise. In the example, you have a constant a constant b, and later on you use tf.add to add them together and return the result in C. So C is a tensor that you need to evaluate, so you would create a session, and within the session you evaluate C using ses.run C. It returns 3. And this is the syntax for tf.add. tf.subtract is very much similar. So instead of add, you have subtract, and the rest is just the same. And the result is -1 if you evaluate C. tf.multiply return the product of x and y element-wise. So if you create a constant a which has two elements, another constant is b which has also two elements, then multiply tf.multiply would apply multiplication on a and b element-wise and returns the result in C. So in order to evaluate the tensor C, you would do the same thing, create a session and then evaluate the tensor using ses.run C, and that would return a list containing 2 and 6. The syntax very much similar. And tf.divide is very much also similar as tf.multiply. Instead of multiply, now you have divide. And with the same similar example, the input a list of 2 elements 4 and 4, and another is 1 and 2. The result is 4 and 2. And this is the syntax. You can also have matrix multiplication. In this example, you create a constant a and another a constant b, and then apply the operation matmul for a matrix multiplication on a and b, and you have the tensor C. In order to evaluate this, you repeat the same thing, right? In the session, write ses.run C to evaluate C, and the result is here, a 2D list. How about conditionals in TensorFlow? How can you write if conditions? So tf.con returns true function if the predicate is true, otherwise it returns false function. On the right of the slide, you see the syntax for tf.con. So following the syntax, you can write the condition. But let's go back a little bit. First, you create a constant t1 and another a constant t2. And then you define a function. f1 returns the addition of t1 and t2, and f2 returns the subtraction t1 minus t2. And then you write the condition tf.con, meaning if, right? If and tf less, right? Check if t1 is less than t2. If T1 is less than T2, then return F1, otherwise returns F2. And then evaluate, this is the tensor rest, and then evaluate the rest in a session. And that would return 3. Next, let's see how you can write while loops in TensorFlow. So in TensorFlow, you would use tf.while loop. This repeats the body while the condition con is true. Right? So basically, this is syntax, but you would focus on the first 3 arguments: con, body, and loop vars. Loop vars is for loop variables. In the example, first you define the function for the condition, right? Con with 2 arguments, T1 and T2. So this returns true if T1 is less than T2, and otherwise it returns false. And another function for the body, namely body, with 2 arguments, T1 and T2, and this function returns the addition of T1 and 1, and also T2 in a list. Later on, you create 2 constants, T1 and T2, and then pass the constants to the while loop. So the while loop, while the condition is true, then repeat the body, and you fill in the constants T1 and T2 as the loop variables. And returns the result in the rest. So you have this tensor, and you would evaluate the tensor the same way as we did before. The output will give you a list 5 and 5. Basically, it loops through, and when the condition is true, still true, then just repeat the body. And T1 and T2 was the initial values. Now, you may have a question: where does code run? Here we talk about GPU and CPU. GPU stands for Graphical Processing Unit. If you have a desktop computer and you look at the back of the computer, then you may see something like this, And if you open up your computer, you may see, if the computer has something like this, then it is the Graphical Processing Unit, or GPU. Computation would be very fast if you run them here. CPU stands for the Central Processing Unit. And on a typical computer, and there may be multiple computing devices, you may have CPU, one or more, or you may have also GPUs as well. And if a TensorFlow operation has both CPU and GPU, then usually GPU device would be given priority. You can specifically tell TensorFlow where should it run the code. If you want to run your computation on CPU, let's say the first CPU, you want to say with tf.device and give it a string specifying which CPU you want to run. So you want to say slash CPU and semicolon and then 0 to say this is the first CPU. In TensorFlow, you can create a session with log device placement set to true. In order to return you the information, something like this, that tell you exactly where your computations run. So here you can see B, the tensor B is on GPU 0, A is on GPU 0, modmul is on GPU 0.